Hello everyone, welcome back to our channel. Today we are diving into an exciting LeetCode problem called repeated DNA sequences. This problem is an excellent way to sharpen your skills in string manipulation and optimize algorithms for efficiency, skills that are often tested in coding interviews. By mastering this problem, you will not only improve your ability to handle and analyze substrings, but also learn to optimize your solutions using advanced techniques like the sliding window approach. So let's get started and reveal the key techniques to conquer this engaging problem. So in this problem statement, we'll be provided with a DNA sequence which will be represented by a string, and this string consists of 4 characters, that is A, C, G and T. And what we'll have to do is we'll have to return all 10 letter long sequence or substring that occur more than once in a DNA molecule. That is, we'll have to find all such 10 letter substring within the string which will occur more than once. So for instance, in this example, if you see the input is a DNA sequence, and here within this string there are 2 substring which have occurred more than once. So this first string have occurred more than once within this substring, and this second substring have also occurred more than once within this string. So the challenge is to identify repeated 10 letter sequence or 10 letter substring within the given DNA sequences efficiently. So now let's look at the approach. Before discussing the optimized approach, let's see the brute force approach. So in the brute force approach, we'll initially take the first 10 character long substring and we'll compare it with rest of the substring. Again, we'll take the second 10 character long substring and we'll compare it with rest of the substring. Then moving forward, we'll take third 10 character substring and we'll compare it with substring. So we'll repeat this process. Okay, we'll pick one substring and compare it with rest of the substring, and we'll repeat the comparison process for all the substrings. So you can clearly understand from this that when we'll implement it, we'll have to use nested loops for comparing each substring with the rest of the substring. When we pick first substring, it will run a loop. When we compare this first substring with the rest of the substring, then it will have to run another loop to find all the rest of the substring and compare it. Okay, so this will result in a O of n square time complexity. So now let's look at the optimized way, and the more efficient way to solve this problem is by making use of sliding technique along with hash sets. So what we do in this approach is we'll have a sliding window of 10 character long, where start will be pointing initially at 0th index and the end will be pointing to the 10th index, right? And in each iteration we'll extract the substring from this sliding window, and by making use of hash sets, mainly a seen hash sets and a repeated hash sets, if the substring has been already visited, that means it would be a repeating substring, so we'll put it in the repeating hash set. And if it has not been visited yet, we'll put it in the seen hash set, so that next time whenever the same hash set has been encountered anywhere within the string, then we'll see that it has already been visited since it is present in seen hash set, so we'll put it in a repeated hash set. So finally, our repeated hash set will consist of all the substring that are being repeated. So let's understand this with an example. So we have taken this string initially, and initially we'll have our sliding window where there will be start pointer pointing to the initially pointing to the 0th index, and end pointer will be pointing to the 10th letter, that is in the 9th index, and we'll extract the substring from here. So what will be the substring initially? So initially it will be this, that is A, C, 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 C. And initially, since it is not present in seen because seen is empty, so we'll put this substring in our scenes hash set. Now after putting this substring in seen hash set, we'll move our sliding window and extract this substring, and we'll check whether this substring is present in our seen hash set or not. Since it is not present, that's why we'll put inside in this scene has sets. Now in third iteration, we'll move this forward and we'll check this substring whether it is present in scene has set or not. It is not present, so again we'll put this substring in our scene has set. Now again we'll move forward here till here. Now moving forward, we have put two more substring here because these are also not present in our scene has sets. Now we'll move forward and we'll see that this substring is also not present in our scene has set. Now we'll repeat this process till here and we'll see that all these substrings are not present in our scene has set, and we'll move forward similarly. So we'll put all the four substring here. Now at this point of time, if we again move forward in our next iteration, we'll see that this particular substring is present in our scene has set because A 5 times A and 5 times C was initially present here, right? So this substring and this substring is matching. So what we'll do is we'll put this, since this substring is repeating, so we'll put this substring in our repeated hash sets. So we'll put this substring here. Now we'll repeat this process till here and we'll see that all the substring that we find till here is not present in our scene subset. So we'll add it here. So now moving forward in our next iteration, we see that this substring is present in our scene set here. This is already visited here. So initially this was matching. We have found our first repeated set. Now we have found our second repeated substring as well. We'll put this substring in our repeated set. So we've got our second repeated substring. Now after this, in a similar way, we'll traverse this sliding window till we reach the end. And we'll find that till end, all the substrings are not present in our scene set. Okay. So at the end of our iteration, we finally have our scene hash sets, which will be all the unique values, and repeated hash sets are those substring which has been repeated. So these are overall logic that while iterating, if any substring has been observed in scene hash set, that means it is repeated and we'll put it in a repeated hash set. Otherwise, it will go inside our scene hash set. So finally, we'll have repeated as our output. But in our problem statement, we are asked to return a list. But in our approach, we have used a hash set. And the main reason of this is because suppose if there is a substring that has been encountered more than twice. So if it was a list and we'll add those substring here, then we'll have a repeated value. So to avoid that, we are making use of a set so that even if 100 times if you visit the same substring which is observed in scene hash set, we'll still put that value only once in the repeated hash set. And finally, when we are returning, we'll convert this hash set into a list and we'll return this. Now regarding the time complexity, since we have observed that each substring is encountered only once, right? So our overall problem simply involves sliding this window. So in each iteration, it will move like this. So since each substring is checked only once, so time complexity is O of n. And regarding our space complexity, we have hash sets. It will store all the substring. So our space complexity would also be O of n into the length of each substring, that is into 10, which is constant. That's why it will be O of n. So our time complexity is O of n and our space complexity is also O of n. So these are overall approach to solve this problem using sliding window and hash sets. Now let's look at the coding. Initially we'll have a n, that will be the length of string. Then we'll have two sets, that is scene set and a repeated set. Now we'll run the loop. We'll run the start pointer till So our start pointer will start from here, from 0th index, and it will move like this and it will reach till here. So we don't have to run till n, but our start pointer should point till the 10th value behind the n. So that is 32 minus 10 is 22, and so our range needs to be till 23. So to get this value, 32 minus 10 plus 1, 32 minus 9 would be 23. Okay, so we'll have to run till here. Right. Boundary should be 23. So it will be from n minus 9. Okay, so now we'll extract our substring from this sliding window. So our sliding window would be s of start and end. And what is our end? End is nothing but start plus 10. Now in each iteration, what we'll check is we'll see if this substring is already visited or not. If it is already visited, that means it is a repeating substring, right? So we'll repeat it, we'll add it in the repeated set like this. And if it is not, it will go in the scene hash set. This is. Since our scene, all the values would be present in our, all the unique values would be present in our scene hash set. Even if we don't add this else, it will work. Because even if you are trying to put the same value once again in the scene hash sets, then it will not happen. We will get the unique value only. So now finally we'll have to return the repeated. Our output will be stored in repeated hash set, but we'll have to repeat the list of this. So we'll convert this set into a list and we'll return it. That's our overall code. Let's run this. Cool. Now let's submit this code. Awesome. And there you have it. A clear and efficient solution to repeated DNA sequence problem. By using the sliding window technique and sets, we achieve an optimal time complexity of O of n. If you enjoyed this video and found it helpful, don't forget to give it a thumbs up and subscribe to our channel for more coding challenges and interview tips. And don't forget to hit the bell icon to stay updated with our latest uploads. If you have any doubts or suggestions, feel free to leave a comment below. I'd be more than happy to assist. Thanks for watching, and I will see you in the next video.